Good morning, afternoon, and evening to all of you from wherever you are joining us today. Before we start today's session, please feel free to do event checking. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access links from today's session. I will share the event check-in link with the event ID in the Q&A section shortly. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor, Bengaluru, India. This session will run over the next 60 minutes including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Nilesh, our speaker for today's session. He is data architect with 18 years of industry experience in finance, retail, and healthcare domain. Well, when he's not thinking or talking about technology, he likes watching cricket. But for now, I will hand over to Nilesh to begin the session. Over to you.
Thanks, Rashmita. Let me try sharing my screen. Please confirm once you are able to see it. Can you see my slides?
Yes.
Okay. Thank you. Thanks, Rashmita, for the introduction. Welcome, everybody. So today we'll be talking about event-driven autoscaling with Kubernetes-based event-driven autoscaling project or KEDA. And before we start with KEDA, let me share some of the social media links with you. In case you are interested in connecting with me, please feel free to use any of these social media handles. And I'm also one of the co-organizers of the Azure Singapore user group, where we also organize events similar to what Reactor is doing. And I've put a short link or bit.ly link here to our YouTube channel, which are also recordings of all our virtual sessions that happened during last 1.5 years or so. So feel free to subscribe to our YouTube channel as well. Now, before we move on to today's session, a bit of background about myself. I was born and brought up in Goa, and you might be aware of Goa from your visits to Goa, or you might have seen some of these beautiful places in Bollywood and other movies as well. Goa, if you know, it's a beautiful place filled with churches, beautiful beaches and temples as well. So I did my schooling, studying everything in Goa, and then I moved to Bangalore. I was in Bangalore from 2003 till 2010 before I moved to Singapore, where I'm currently based. So coming back to today's session, we'll be talking about what are the different options for scaling in Kubernetes. Then we will look at the overview of KEDA. Where does KEDA fit in when we talk about Kubernetes? Then we will see a live demo with something called as Tech Talks, a small application, which is like a event management demo application, which is interfacing with RabbitMQ as a messaging queue. And we will see how to automatically scale that using KEDA. And we'll also look at the KEDA architecture. So before I move on to the KEDA or Kubernetes, here are some of the prerequisites for today's session. This is intermediate to advanced kind of session where we're talking about things like Docker, containers, orchestration using Kubernetes. So I expect you to have a bit of background in terms of what is Docker, what is Kubernetes, where does Docker and Kubernetes fit in, then how does container registry come into the picture? You might have used something like Docker Hub or some private container registry like Azure Container Registry. And I will be using Azure Kubernetes Service or managed Kubernetes service here, AKS. So if you have a bit of background about AKS, that would also help. But it's not really a hard requirement, I would say. Whatever I'm showing here will work with any Kubernetes cluster for that matter. Let's start by looking at what are the different options we currently have when it comes to scaling in Kubernetes. And before I talk about scaling in Kubernetes, let's talk about why scaling is important. If you see last 5 to 10 years, cloud adoption has increased a lot. And with that, there is this shift in the way we were building applications. We nowadays see cloud native applications where the kind of patterns which are used to build and deploy these applications are different compared to what we were doing before the advent of cloud. And nowadays we see a lot of cloud features being used, or even if we are not on cloud as well, still the principles or the guiding patterns which are available for cloud native applications can be used even otherwise. So you have things like elasticity, you have things like scaling, which allow these applications to provision resources on demand and also use your resources optimally. So like 10 years back when we needed a very powerful kind of system to be built, we would over provision the hardware, we would over provision the servers, we would over provision our databases. Nowadays, that's not the case. You might have heard about serverless, which allows us to do operations or execute code based on some events. So we are moving more and more towards a scenario where the compute resources are optimized based on the resource usage or based on what is exactly required at that point in time. And from that point of view, I would say Kubernetes plays a very big role in this by being a sort of default orchestrator nowadays for cloud native applications or for applications deployed on Kubernetes clusters. It offers various options. So if you look at the screen right now, I've listed down 3 options here where you have first one, which is the horizontal pod autoscaler or HPA. This one allows us to scale a particular kind of resource which can be scaled, like a deployment, for example, by defining amount of resources. So we can allocate the number of resources in terms of CPU or RAM, and we can define thresholds saying if the CPU usage for a particular deployment or the usage of memory goes above 70%, then you can scale the deployment and the horizontal pod autoscaler will then scale within a range. So we can say you increase the number of replicas to let's say 5 to 10 and assume that your current replicas are 2, then as far as as soon as the resource usage hits the threshold, then the HPA will come into the picture and it will try to scale the deployment or scale the resources. That's one option. The second one is the cluster itself can be scaled. So the horizontal pod autoscaler works as long as you have enough resources on your cluster. Assume that your cluster is shared by multiple teams and then you hit a limit at the cluster level itself. So your HPA got triggered and let's say you have given the number of replicas as 100. 80 replicas got created and then all of a sudden the Kubernetes realizes that there are 20 pods waiting or there are workloads which are waiting to be scheduled. In that case, we can enable the cluster autoscaler as well, in which case the underlying nodes at the Kubernetes cluster, those will be added dynamically and these pending resources which are waiting for allocation of resources would be scheduled to run on those additional nodes which are added as part of the cluster autoscale. And the last one is manual scaling, where you do the scaling yourself by using, let's say, a command line tool like kubectl. You go into the terminal, and this is an example I would like to show here. I have a particular deployment which is named as RabbitMQ producer deployment here. And for some reason, let's say it is not processing fast enough. So I'm increasing the replicas from currently deployed 2 replicas to 5 replicas. So you can see that once I run that kubectl scale deployment command and give replicas as 5, it has scaled the number of replicas. And then if I try to get the number of deployments or the replicas, I see it is 5. Then I can same way reduce it back. So a manual step again to revert it back to 2 replicas. I can change the replicas parameter to 2 and it will go back to 2. So these are the options which are available within Kubernetes or by default with the Kubernetes. Now, this works when you know what are the exact number of resources that are required and you have enough resources at your disposal which can cater to these kind of needs. And you have to be very good at cluster sizing. You have to be good at provisioning resources and estimating resources for your workloads. You need to know how much your pod that is running on this cluster needs to have in terms of the CPU and the RAM usage. But in certain scenarios, this might not be the case. Let's say you are having some sort of promotion and you don't know how much amount of workload that is going to come on a particular day when your promotion is open to the public. Let's say it's a festive season, for example, Ganesh Chaturthi, Deepavali, Christmas, or any of those festivals where you have a promotion going and the load can be totally unexpected. In such scenarios, these kind of metrics which are used by the Kubernetes default APIs or provided by the Kubernetes by default may not be sufficient. And that is where we have to look at other options, and that's where KEDA comes into the picture. So let's first start by looking at our application and the demo of that, how the application is set up, what I'm going to use for today's demo. I have this small application called Tech Talks, and it has got two components, the producer and the consumer. Tech Talks producer is a .NET Core API. It has got two replicas deployed onto the cluster. Or when I do the deployment live, you will see that it will create two replicas. It is exposed as a Kubernetes service using a load balancer. Then on the consumer side, we have a .NET Core EXE. And since this runs as a EXE, I don't really want to expose it outside the Kubernetes cluster. So this is accessible only within the cluster. And this consumes the number of messages from a RabbitMQ. So the producer, it can produce a configurable number of messages. And when the consumer starts, I can configure the consumer to say, pick 50 messages in a batch or pick 100 messages in a batch. So that the batch size of the number of messages that it picks up at a time for processing is very much configurable. And in the middleware or the messaging layer that I'm using is RabbitMQ. This one I'm deploying using what is called as a Helm chart or a package manager for Kubernetes applications. So what this allows me to do is I don't have to write the manifest files myself. It gives me a package that I can just customize based on my needs. I can override some of the default settings and the whole RabbitMQ cluster would be set up for me on top of my Azure Kubernetes Service AKS cluster. So all these three components, they are running inside my Kubernetes cluster. And this is how it looks like. So we will configure the number of messages. We can take any number of messages to populate onto the RabbitMQ, and then the consumer will consume those many messages. So let's go into the demo mode and see this in action. So I have one cluster here, which I have created just a few minutes back or maybe just an hour back. And I just have RabbitMQ installed on this. This doesn't have any other things running. So you can see that if I run the kubectl get nodes command here, this is created about 120 minutes, so about 2 hours back. And if I get the pods which are running on this using one of the alias, it is running RabbitMQ. So there are no other pods running on this one. I also use a visualizer for visualizing the state of the cluster. This is called as Octant. It's an open source visualizer for your Kubernetes cluster. And again, I can see the complete state of my Kubernetes cluster here. And we can cross verify that it is exactly the same what we saw on the command line. So when I look at the namespace overview, I should see in the pods, there is only one RabbitMQ pod running. And behind that pod, there is a stateful set. In terms of services, there is the RabbitMQ service, which is exposed by the Helm chart. So that's the only service which is running right now. And it has got some persistent volumes and secrets and things like that. So now let me go and deploy the application on this. So for the deployment, I have some PowerShell scripts which are there in my GitHub repo. You can refer to this after the demo. So I will use one of this script to deploy the TechTalks application. So as I said in the slides, I'm going to deploy the producer. I'm going to expose it as a service and then the consumer as well. So now I've deployed all these three components and this PowerShell script which I just ran. You can see in the output that RabbitMQ consumer deployment was created, producer deployment was created, and the service was also created. Before we move on, let me show you quickly the code for this, how these things are in Visual Studio Code. Something wrong with the Visual Studio Code. Let me just stop the presentation mode and go back. Okay. Okay. So let me show the producer code first, the API code. So in my SRC folder, I have the TechTalks producer, and in here I have the controller. And there is one method on the controller, which is the generate TechTalks. This takes the number of messages to be generated, and it uses something called as faker. So I'm using a third-party library, which is called Bogus, which allows me to fake some of these objects, and I can create my data model here using this faker. So this is quite helpful if you are doing unit testing and you need to generate some sort of data, random data. So here I'm just setting all the properties, things like what should be the name, how it should contain random numbers and stuff like that. And then I generate those many number of messages and then I send them to a message queue. So let's look at what happens inside this message queue component. So this is the core where the producer is producing the messages and writing it. There are three main properties here. One is the RabbitMQ host name, and then the credentials to connect, username and password. These are all configured as the configuration settings. And in the send messages method, it takes that collection of the messages or the TechTalks, and then it will create a connection to that RabbitMQ. And it will serialize all this into a JSON object, and then it pushes that onto the queue. And on the consumer side, just the reverse of this happens. So if we go back onto the .NET Core exe and we look at the consumer, we see that the properties are similar in terms of the host name, the credentials for username and password. The difference here is one additional property, which is that batch size. So again, all these four are taken from a configuration value, and we can override them so that they can be changed across different environments. And the consumer connects to the same queue where the producer is producing the messages. And when a message is received, it will deserialize that from the JSON object. And to simulate like a heavy workload, I've just introduced a sleep of 2 seconds. And then we just log these details to the standard log. So that is what this whole application is doing for now. So now let's go back and generate some workload. So if I look at the resources now, or the services, we see that there is a RabbitMQ producer service, and this is exposed on this 175.89 IP. So I will use Postman to call that web API. And instead of 4,000, let me populate 2,500 messages. I can also get a nice UI for RabbitMQ. This is again coming from that Helm chart. I've already port forwarded to that port 15672. So if I go into my browser and if I hit 15672, I should be able to see the RabbitMQ UI. And I can go into the queues here. So we see there is a queue called hello right now, but there are no messages available. So the queue is empty currently. So let's go and generate some messages here. 2500 is what I'm going to generate. We got the status OK 200. So those 2500 messages should be published onto this queue now. So you can see that it has 2500 messages and 75 messages have been picked up by that consumer. There is one consumer running and the prefetch count or the size is configured to be 75. And now this will continue for processing these 75 messages. Then in the next batch, again, it will pick up 75 messages. And if you look at this, this will go on until all the 2500 messages are picked up. Now, if I go back and look at the resources that are allocated for that consumer, when I deployed it onto the Kubernetes cluster, we can go into the K8s folder, and that is where I have the manifest files. So if you look at my resources that I'm allocating to the consumer, when the consumer is created or the scheduling is happening, I'm requesting for 1% of the core, 10 millicore and 150 MB of the memory. And the limits that I've set is it can go up to 5% of the available cores and it can utilize up to 400 MB. So this is good enough for processing those 75 messages that it has picked up in the batch. Now, assume that scenario where I configured the horizontal pod autoscaler and I configure it to say when the CPU goes above 80%, you start scaling. In this case, because I have that prefetch size of 75, I might never hit that limit, or I might never crash pass that threshold or cross that threshold of 70% or 75% of the CPU utilization. So in this case, what would happen is there would be only one consumer and it will take quite a long time to process all these 2500 messages. So in this kind of scenario, instead of looking at the traditional matrix like the CPU or RAM, we can look at a different kind of matrix. So in case of messaging system like RabbitMQ, we can look at the number of messages which needs to be processed, and then we can scale automatically based on the number of messages. And that is where KEDA comes in and it helps us to do all this. So let me go and deploy one more thing which is related to KEDA. And before we do that, let me show you if there are anything called as custom resources. So when KEDA deployment happens, it deploys something called as the custom resource definitions. So these are like custom objects which are provided by KEDA. So if I currently look on my cluster and if I say kubectl get CRD, which is for custom resource definitions, I would find 3 custom resources which are created by default by the Kubernetes cluster. So this is the storage snapshots. I don't have anything related to KEDA at this point in time. So let me go and deploy KEDA first. So KEDA again is deployed using the Helm chart. And while the KEDA installation is happening, let me show you that PowerShell script where I'm using the Helm chart to deploy KEDA onto my cluster. So I'm creating a namespace called KEDA here, and then I use Helm 3 to install KEDA from the KEDA core repository. And KEDA core repository is pointing to GitHub repository where the KEDA charts are available. These are again provided by the KEDA project, and I get those charts locally onto my machine. using this when I do Helm install or when I do Helm update. It will get the latest definition of the charts from this repository. And then I'm pinning this to 2.4 version, which is the latest version of KEDA. And I want to deploy it in the namespace KEDA, which I created in the above line. So if everything goes fine, now KEDA should be deployed onto my cluster, and you can see the output of that Helm install. It says that the KEDA has been deployed. Now, if I go and look for the custom resources again, I should find some additional custom resources created by that KEDA deployment. So let's look for the CRDs again, and you can find this .keda.sh some resources. There are 4, in fact, custom resources which are created by KEDA. So we have something for the cluster trigger authentication. We have something called a scaled job. We have something called as scaled objects, and there is something to authenticate the triggers. So these are 4 objects which are created by KEDA, or definition or templates provided by KEDA, which we can use in our application to scale based on the KEDA project. So now let's see how can I use KEDA. Let's go back to the RabbitMQ and see that still it is only one consumer, and it is still taking its own sweet time to process those 75 messages in a batch. Now I want to deploy the autoscaler for KEDA and see what change happens. So before I deploy the autoscaler, I want to set a watch on my deployments and on my pods. So on the top of the window, I will set a watch on my current pods. So when I run kubectl get pods, you can see that there are 4 pods running, one for RabbitMQ, one for the consumer, and 2 producers. For the producers, there are 2 replicas. I will set a watch on the deployment as well to see which all deployments are managing these pods. So if you know Kubernetes, the way the objects are organized, these deployments are a higher level construct which internally create these pods. So there are 2 deployments in the default namespace. There is one for the consumer and one for the producer. And we can see right now there is one instance or one replica of the consumer running and 2 replicas of the producer running. Now let me go and enable or add some objects for the autoscaling. So again, I'm running a PowerShell script here, which will deploy some manifest files, which we will have a look quickly. So as a result of running this PowerShell script, you can see that it has created a secret. It has created a RabbitMQ consumer scaled object, and it has created something called as trigger authentication. I will show you those files in a while, but have a look at this output for now. You can see that immediately there is an increase in the number of pods, the consumer pods specifically, and the deployment also is increasing. It went from 1 to 2. Sorry, it went from 1 to 4. Then when 4 replicas were available, it realized that 4 is not good enough. It tried to scale to 8. Again, when all the 8 were ready, it realized 8 is not good enough to pick up all those messages or process all those 2,500 messages. So it is trying to scale to 16, and even 16 will not be good enough. So it will go to 30. That is what is the limit which I have set. So now what has happened is within a minute or less than a minute, we see that the scaling is happening for the consumers. And if I go back into the RabbitMQ UI again, you see 16 consumers are already up and running, and now within a second, while I was speaking, all the 30 consumers are up now. So all 30 consumers are running. Each one of those consumer is picking 75 messages in a batch, and that processing is happening in parallel now. So how did all this happen? So let's go back into Visual Studio again. And let me close this. Let's go back to the manifest file for autoscaler and look what did it do. So I will skip the part related to creation of a secret and the trigger. It is just a connection or a link. the main crux of all this is something called as a scaled object, which is the custom resource definition provided by KEDA. So I'm using that and I'm creating a new object, just like a deployment or just like a pod or just like uh, stateful set that is provided by default in Kubernetes. I'm using this scaled object type of an object. And in the specification, I'm saying scale target reference in this case is my RabbitMQ consumer deployment. And in order to scale this deployment, there are some metadata that I need to provide. Things like what should be the polling interval. By default, KEDA will look every 30 seconds, but I'm saying look every 1 minute, 60 seconds. Cooldown period is when it tries to scale up or it tries to scale down, how much duration it should wait before the next trigger for the scale in or scale out operation happens. And in terms of the minimum replicas or maximum replica count, I'm specifying the range here. So in this configuration, I've set it to 0. That means if there are no messages to be processed, KEDA will scale down my deployment all the way to 0. And if there are messages to be processed, it will scale it up till 30. And that happens progressively, as you saw when that deployment was scaling in. And the last part is which binds the KEDA to the event source. So that is defined in something called as triggers. And we are saying the trigger for this scaling in our case, in this example, is RabbitMQ. And then we provide the metadata for RabbitMQ in terms of what is the name of the queue, what is the queue length. So this is the number of messages which are still waiting to be processed in that RabbitMQ queue, and then the protocol which needs to be used. And the credentials which we provided in the code, that is set as something called as the authentication trigger, which is set in another object. So similar to this manifest file, you can have a look at that manifest file later. It's just a configuration to say what credentials should be used, and that is stored as a secret. It is not available as clear text. So if we just look at the trigger authentication, it just says that this is a type of trigger authentication. The parameter is the kind of secret, and it should be targeting the host as the name of the parameter, and the secret is that username password. So instead of writing this in clear text, we are storing it as a secret, which is a recommended method or a secure method. And with this configuration now, we are able to scale our deployment or the consumer based on the number of messages. So you can see now that the consumers have scaled down to 0 because all the messages have been processed. Or we still have some messages, but again, for some reason, scale down got triggered. But since there are still messages to be processed, we will see that it will again go back. And let's go and have a look at the watch, where we will be able to see that again the deployment is now going up. So because of that cool off period or cool down period of 30 seconds, there was that cooldown period where for 30 seconds there were no consumers running. But again, it finds out that there are messages to be processed still, and that is where you see this scaling in happening again. So we saw both ways where the consumer scaled from initially 1 instance all the way till 30. Then from 30, it went back to 0. And now again, it's going all the way till 30. And then we will see that once the messages got processed, it will go back to 0 again. So once those messages will be processed, it should scale down. So that is what KEDA provides us, or KEDA helps us to do. Now let's go back into the presentation mode and look at some of the things from the architecture of KEDA. So how does KEDA do all this? There are two main things which KEDA does. First one is it acts as a matrix provider or matrix server, where it collects matrix not from the objects within the Kubernetes cluster, but from an external source. In this case, our external source was RabbitMQ. So it was able to get that queue message length kind of matrix based on the type of the external source. Once those metrics are available, it links to the external source, as we said, and then it uses this scaled object to go back and leverage on the existing objects provided by Kubernetes. So in this case, we were using deployment. So the scale object binds the deployment and this external source, and it will do the scaling. So behind the scene, it still uses a horizontal pod autoscaler, but the up and down of that horizontal pod autoscaler is something which is managed by that scaled object. And this is depicted very well in this picture from one of the online link which I provided at the bottom. So you can see that KEDA uses the scale controller, and that scale controller is the one which links the scaled object to the horizontal pod autoscaler. And we looked at RabbitMQ here, but it can connect to AWS, it can connect to Azure, it can connect to GCP cloud sources, and it can connect to various other providers. So that auto scaling infrastructure is managed by KEDA. And in this example, you can see that there are 4 different deployments, and all those 4, they might be going to a different scaling target. So it can be Prometheus, it can be Kafka, it can be AWS. But the main crux of this is you need to have some sort of eventing mechanism which KEDA can leverage on. And that scale object will be looking at that external event source, and it will scale your deployments based on that. So we looked at the definition of the scaled object, and I've tried highlighting some of the important parts here, like the kind should be scaled object, what is the scale target reference where it's targeting, and what should be the type of trigger and the metadata. This will vary based on the type of trigger that we use. So in a short while, I'll show you a different example other than RabbitMQ. So combining all this, we can see that in our example, this is how we managed to do it. We had the producer service with 2 replicas. We installed KEDA, which created a custom resource object, or which provided a CRD for us. And then that was the link between our scaled object, which scaled the RabbitMQ consumer deployment, and then the external source was RabbitMQ. So I've also tried to put the screenshots of the important parts of that manifest file here. In terms of the features of KEDA, so first one is it's obviously event driven. It allows us to build applications which are not just relying on CPU, RAM, those kind of metrics. It supports event driven applications and the architectures. It makes auto scaling very easy. We saw how quickly it was able to scale up and scale down, and we didn't even have to modify our application code. It just extends the functionality that is already available within Kubernetes itself. So we don't have to make too many changes to our application. Just by adding a couple of manifest file on top of the existing Kubernetes object, we are able to scale them dynamically or based on these events. It also provides a lot of scalars. As of this morning, there are out of the box 39 scalars which are provided. This can be linked to databases. We looked at messaging. There is a telemetry systems like Prometheus. It also supports various cloud providers like AWS, GCP, Azure. It also supports multiple types of workloads. We looked at deployment here, but Kubernetes job also can be managed. Stateful sets as well can be scaled using KEDA, and it's vendor agnostic. KEDA was started in collaboration by Microsoft and Red Hat, and then it was open source. And now, just as of last week, the CNCF committee has agreed to promote KEDA from incubation stage to sandbox, or the other way around. So it has gone to the next level of CNCF adoption. And it's also supporting Azure function. So it's not just the kind of workloads which are related to pods and things like that. Azure Functions, which is a serverless offering from Microsoft, it also has support for KEDA. So here I've tried to list down some of the event sources and scalars. We can see things like On Azure, it has support for blob storage, Event Hub, Log Analytics, Azure Service Bus, Azure Storage Queues. When it comes to AWS and GCP, it supports CloudWatch, the Kinesis Streams, SQS service, and pops up on GCP. On the messaging side of things, ActiveMQ is supported, Kafka, Prometheus is there. Prometheus is more on the observability or alerting side, RabbitMQ, and things like Redis list is also supported. And in the database side of things, there is MySQL and PostgreSQL as well. So before I go on to the summary, I would like to show some of the links where you can find more about KEDA. So KEDA is available on keda.sh. On that's the homepage for KEDA. You can find about external sources and scalars here. That's the most important part, and you can find all of them. We looked at RabbitMQ in our example. Let me show you what are the metadata or slightly different properties which are required if we have to connect to Azure Log Analytics, for example. So in the trigger, you can see the type as Azure Log Analytics, and the metadata that is required for connecting to Azure Log Analytics is completely different than what we were using to connect to RabbitMQ. So in this case, we would have to provide things like the tenant ID, client secret, then the query, which is required from the Log Analytics, and also things like the workspace ID and things like that. If we look at maybe one more type, let's look at MS SQL or MySQL, not to be biased towards Microsoft. So let's look at MySQL. And here you can see that we need to provide things like the host port, database name, username, and the query as well, which will be used to identify when the scaling has to happen. So that is one part. There is also a set of samples which are available in KEDA. So if you go to the GitHub repo, KEDA core samples, you will find different samples in multiple languages. So let's take Azure Service Bus as an example. You have a .NET Core example. There is a Python example. In case of GCP, there is example for GCP. Kafka, we can see there is a Quarkus example. There is a Dapper based example. So there are a lot of examples available for you to look at if you're looking for a specific external source or event source, and you want to see how that can be scaled, and then you can use this as a reference and build your own example, let's say, or build your own application. Let's say there is no example available in your preferred language, but still you can get the idea of what parameter needs to be passed or what settings needs to be configured from these examples. So based on this demo that we saw, we can see that it's a very single purpose lightweight component. It doesn't really impact anything on your actual code. If you don't want KEDA, you can go back and remove KEDA and your application will continue to work as it was before. It runs on any Kubernetes cluster, which is 1.16 or higher version of Kubernetes APIs. It extends the Kubernetes with event-driven capabilities, which we saw. It doesn't override or duplicate anything, but it adds those scaled object and a couple of other objects to the existing functionalities. And it can map the event sources to things like the native objects of Kubernetes, which is deployment, stateful set, custom resource, or job for scaling. And it supports more than 35 autoscalers. I checked this morning, it was about 39. When I started working with KEDA about a year or just before that, there were hardly about 8 or 9 sources. So the number of sources, they have multiplied almost 5 times over a period of, let's say, 1 to 2 years. And I do see a lot of new sources coming in. So in terms of its adoption and popularity, it's increasing day by day. I would also like to give you some references in case you want to learn more. So if you want to start with Docker, if you don't know Docker, you can use this play with Docker, play with Kubernetes resources. There are also learning paths available on most of the e-learning platforms. And here I've given a reference to Linux Academy, which is currently acquired by a cloud guru. So this one I would have to change to a Cloud Guru in the next session. I've also given links to KEDA and the AKS cluster autoscaler here, horizontal pod autoscaler as well, which I mentioned. There is a wonderful resource when it comes to Kubernetes, which I prefer to, or which I referred quite frequently when I was learning about Kubernetes. It's called 50 Days from Zero to Hero. This is developed by Microsoft in collaboration with Brendan Burns, who is the co-creator of Kubernetes. It's a set of resources where you have short bite-sized YouTube videos. There's online resources as well. I highly recommend this if you want to learn about Kubernetes. And there is also MS Learn module available for specifically Kubernetes or AKS, Azure Kubernetes Service. On my YouTube channel, I have various videos which are related to what I have talked. I have a video regarding, I have a collection regarding KEDA, 3-part series, which was one of the first videos I did. And then there are various videos about integrating AKS with virtual node, with the Azure Container Registry, then Azure Key Vault, things like that. So you might find this useful. I also did a 6-part learning series for the Azure Singapore community way back. Some of this is still relevant. So if you are quite new to Kubernetes, you might also refer to this one. So with that, I would like to conclude this session. The source code is available on my GitHub repo. All the commands that I showed, they are also available in a markdown file. So if you want to repeat this demo later on, you should be able to do it yourself, referring to those commands. So thank you. Thanks a lot for joining this session. You can find the slide decks published on SlideShare as well as SpeakerDeck. If there are any questions, I would be happy to answer them.
We have few questions, Nilesh, and plus I think Ranga also wants to ask questions. So yeah, Ranga, you can unmute and ask a question.
Thank you. It was a nice talk. Nilesh, my question is, why is there a scaling of deployments? Because there needs to be a scaling of pods, because the pods are the ones which will do the processing. So you can still have one deployment having however many pods you want. So that was my first question.
Okay. It's by design with the KEDA architecture. So if you look at the kind of Kubernetes object that it supports, it's targeting deployment and not a pod. Because in a deployment, you can have multiple pods, or you can have a complex deployment which contains multiple sets of pods together, right? Like a sidecar container and things like that. So instead of targeting a single pod, it's trying to target a higher level construct, which is a deployment. And that's the design of KEDA itself. I'm not very sure why it chose deployment instead of pod, but my understanding is it is always better, instead of going to a lower level or a granular object, to target a higher level construct, which is more scalable, in my opinion.
Right, Nilesh. So what I'm asking is, so in this case, when you're scaling up a deployment, again, whatever pod is mentioned in the deployment, you're in turn scaling it up, correct?
Yes.
So my question was, why don't you kind of have an override on the deployment itself to scale it up? In the original deployment, let's say it has 3 pods scale replica, okay? So why don't we override it to say however much we want, like let's say 75 pods and one deployment, the same deployment? Because even though we scale up the deployments, it's going to be a copy of whatever the YAML we give. It is not going to be different. So each deployment, even if it scales up, it is going to be the exact same of the other deployment.
Yes, that's correct. But if you do, let's say you change from 75 to 100, you will have to redeploy that manifest file, right? Or you have to
Correct. Correct.
redeploy. Here we are not redeploying. So that scaling is handled by the scaled object.
Okay. So you're just
So there is
bringing in
no need for
additional.
you to change anything on the deployment. Your deployment is not even aware that
Right,
it's changing, right? So
right,
you
right.
don't have to
So,
touch what is already
right.
deployed.
So exactly. So that way we are. So when you scale it back to the original level, you're simply taking away whatever you deployed in the new instance and just let the Kubernetes handle the original thing. So
Yes.
the better design would have been to make a copy of the current deployment, keep it, store it, and then the same deployment you bring it to whatever upscaling and downscaling you want. And at the time of removing or deleting this KEDA, copy back that original thing was my point of it. Because the reason why I'm telling you this is, see, when I want to debug, right? So if I
Hmm.
have like say 18 deployments, it becomes such a problem for me to go into each deployment to see where the problem is, to go into granularity.
Oh no, it's the same deployment. It's not 18 deployment. It's still
Instances,
scaling the
instances.
underlying replicas itself. So the deployment is same. So let me go back to the terminal, and maybe that was misleading on my part. So you see the deployment, right? RabbitMQ consumer deployment. It is still the same deployment. You see the time as 35 minutes here, right?
Right,
It is the same deployment and it's using the same construct what you're trying to explain. But
right,
what's changing here is the pods or the underlying pod that it is scaling. This one you will see on the top window changing from 3 seconds here, and it might be something different when the pod comes up and goes down. But the deployment doesn't change. It is still the same deployment, only the replicas are changing. So it is doing exactly what you are trying to say.
correct. I totally agree with it. Only thing is I'm trying to see, was it a design issue where this issue in the sense, let's say if one of my pod fails, okay, for whatever reasons, in and I have to map that pod to which deployment it is.
The deployment is same. So that's what I'm trying to say. It's the same deployment the first time which I did as part of my initial when I deployed the Tech Talks applications, all the manifest files where it created the consumer deployment and two replicas for the producer deployment. So I'm not
Okay.
changing anything in that deployment as such.
Okay.
And the
In
KEDA
case
is
of,
just trying to increase the replicas of that deployment.
okay, so would this help in my debugging in any way?
Debugging in this kind of dynamic environment, right? It's always challenging. So that is where if you look
Okay.
at the 12-factor application guidelines, they
Mhm.
say that you should use a centralized logging and monitoring tool.
Ah,
So
ah,
for debugging, you would have to then redirect your logs into something
right,
like Elasticsearch or Azure Monitor or whatever your preferred centralized logging framework or target is.
right.
You cannot rely on individual pod or individual object here. You have to use centralized logging, and that is how
Yeah.
you will address the debugging issues.
Yeah, because let's say the deployments, there are 30 deployments, replicas, 30 replicas,
Yeah.
and in that 10 of the replicas is deployed to another node. Let's say for
Mm.
example.
Yeah.
So if those pods in those 10 replicas fail, then I have to trace back to see which deployments they are, like those kind of things. Is that was what I was trying to get at.
Yep,
Yeah.
I get your
So
point.
there is
So
one more thing here,
this, I
Ranga.
would say, is a very real life problem where wherever you do scaling, dynamic scaling like this problem will come, and the solution for that is to use centralized logging. You
And
cannot even rely on the containers log if you're
yes,
writing that to, let's say, the file system of container or that node, because your
right.
node itself might be scaled out or scaled in.
And one more thing is, this is totally a business logic, right? So why are we bringing it back to the platform level? Why can't we handle it in the business layer itself? Is my curiosity.
Yeah.
I don't know.
And there is one more point, I think, because the way Ranga is proposing, if that happens, what will happen? You will immediately scale to 75 replicas, which might not be the case, because I think what Nilesh was trying to say, that they will gradually increase 5, 5, 5, like that, right, Nilesh? Or you
Yeah.
suggested that it will immediately go to 75.
That you can control via these metadata parameters. So
Correct.
for the demo purpose, I've given the queue length as very less, 5.
Yeah.
So
Yeah.
as long as there are 5 messages, it will keep increasing. But
Correct.
ideally, you will keep this much higher.
Correct.
The other one is these two, the polling interval and the cooling down period.
Correct.
So this one, again, for demo, I've kept it as 1 minute, but usually this will be like 5 minutes or 10 minutes so that you have enough replicas running and you take a certain threshold into account, let's say within 5-10 minutes or maybe
Yeah.
even 1 hour,
Yeah.
then you will scale beyond this limit.
Yeah.
So
So
that
yeah.
can be controlled via these parameters.
So that's why I think the approach what KEDA has taken makes sense, because you are gradually increasing. You're not just
Yes.
saying boom, go 75. You are saying,
Correct.
okay, go
Right.
slowly, slowly. And
Yes.
as Nilesh mentioned, in container world or in Kubernetes world,
Right.
for logging, we don't depend on the containers sort of logging. We depend on third party logging, where we are pushing all these logs to some elk stack or
Sure,
some
sure.
Splunk or
Agree,
something.
agree, agree. Because that is total granularity. But not everybody can afford Splunk or Elastic, because those are very expensive solutions. Believe me. So that way, that is. Let's set that logic apart. I mean, I totally get it. In my what I was suggesting was we are directly going to 75 in one shot. Whereas
No,
in
no, it is
KEDA,
not. It is not going to 75 directly. Here
correct.
it is going because I have
Step
kept those thresholds very low.
row. Okay. And again, coming back to the point was this is a total business logic kind of a scenario. So could we not have handled this in the business layer itself? Is there a possibility?
You can handle it in the business layer, but then uh, how would you tie it to the infrastructure? Because nowadays infrastructure is quite dynamic, right? You have things like you can have the whole environment created as part of your CI/CD pipeline. If that
Uh-huh.
becomes the part of your business logic, then you're tying two different aspects together. One which is related to the infrastructure, and the other one which is related to the business logic.
Okay.
So I
And
prefer to keep the business logic separate and the infrastructure scaling and those kind of things separate.
okay.
So I'm trying to handle the business logic part by limiting the batch size. Otherwise, I could have just said pick all 2,500 messages in one batch. But
Okay.
again, that's not a good approach, right? I won't
Right.
be able to scale in that case. So in
So
order for me to scale, the way I'm handling it at the business logic layer is I'm limiting the number of messages that I pick in one batch.
okay. So Kubernetes, this KEDA is as a sidecar, or is it something else?
No, it creates these custom resources and it
Here it
uses
is.
this its own metrics, right? So
Okay. So
that is what I was having in the architecture of KEDA. And if you look at those custom resources which are created, there are only four resources that it creates behind the scene.
and how does Kubernetes give priority? Will it give priority to the original deployment or to the KEDA? Who decides that priority?
That is decided by KEDA because it adds a sort of extension on top of existing Kubernetes objects, right?
How do you how
So
do you how do you ensure that
let's
it
say if
adds
you
an
have
extension?
both, you have a horizontal pod autoscaler as well as KEDA. I would say that's a kind of catch 22 kind of scenario
Right.
where you shouldn't try that kind of thing. Horizontal pod autoscaler, in my opinion or in my experience, is used when you know what is your limits, how much your pod is going to consume, and how much is the range between where it should start
Right,
scaling
Nilesh.
up.
Right, Nilesh. But what I'm saying is, who decides that priority? Whether should I go for autoscaler when both are deployed at the same time, right?
Mhm.
So now, how does Kubernetes make a decision?
That one will be decided by the Kubernetes APIs because KEDA would enhance the existing APIs, and I'm not sure which one it will give precedence, whether it would give precedence to KEDA or it should give precedence to the built-in ones. But
Exactly.
my understanding is it is not overriding anything existing. So it's just extending it. So
Okay. Okay.
maybe by default, it will give the preference to the existing ones and then to KEDA.
Right. Right.
But I
Right.
would not recommend having both in the same kind of application,
Sure. Sure.
because
Sure.
the kind of problem that KEDA is trying to solve is where
Right.
you have unpredictable workload and you need to scale based on that. So
Totally.
that's the
Totally.
kind of problem statement where it tries to cater to that. So if you
Totally.
know your workloads are predictable, you
Right.
would rather be using something like horizontal pod autoscaler. But
Right.
one
Right.
disadvantage with HPA is it cannot scale down to zero, which KEDA can do.
Okay. I
So
mean,
you can use
adding.
your cluster resources better in that sense. Let's say your workload is running only for a particular duration of time, and you have a shared cluster, which is currently happening in many organizations where multiple teams use the same cluster. So you don't want to have these, let's say, pods or deployments occupying even the least amount of resources if they are not getting used. So you
True.
can optimize your cluster usage by having something like KEDA, which can bring down the deployment all the way to zero, and only when there is a need, it can scale it up.
True. My only suggestion was a tool may not be a solution for all the problems.
Yeah.
We have to be judicious in learning new tools also, because already Kubernetes is a monster. Now, if on top of it, if we are going to write every problem as a new tool, sidecar and add-ons, it's going to become like a one big monster. That was
Yeah,
my
that's
only.
true. That's true. Yeah.
Sure. Thank you.
Thanks, Anga. Thanks for those questions.
Yeah,
I hope I
Nilesh,
answered you
one
correctly.
more question, Nilesh. Yeah. So I saw you are reading the RabbitMQ queue length through some code in KEDA. So can we look at that code? Is that code somewhere available somewhere?
Oh, yeah, yeah. It's all available on my GitHub repo. So
No,
if you go to this repository, right,
yeah.
I've given the link in the slides, and the slides are already published. So if you go to this Nilesh Gule PD Tech Fest 2019, you will find all the code there.
No, I'm not looking for the script files. I'm looking for how
Everything.
KEDA calls the RabbitMQ API, passing
Yeah,
the
yeah.
queue name.
Yes,
Yeah,
everything is here. So
everything is
if you
there.
go
Okay.
to autoscale consumer here, you look at the RabbitMQ scaled object, you will find this code here.
No, but this is not the code. This is just the configuration. So this configuration, somewhere behind the code, there is a class which taking this RabbitMQ and passing the queue name
Oh,
and
yeah, that one you can go to the KEDA core. Go to the
okay, KEDA
KEDA core
core. Yes, yes.
repository. That
Okay.
code is all available on the KEDA core.
Okay.
So if you go to the KEDA repository on GitHub, you will find that code.
Okay. Okay. Thank you. Thank you very much. Yeah.
Yeah. Any other question?
The only thing is after I think it's like 12 years I have heard your voice. I'm your previous colleague from Tesco. Your voice has not changed. It's
Oh,
still
is it?
same.
Sorry, who is
Yeah.
this?
Jitendra Sharma. I'm not sure you remember me.
Oh, Jitendra. Nice to
Yeah.
hear your voice, buddy.
Yeah.
Okay, I think if there are no other questions, we can close this here.
Nilesh, I'm sorry, I am not sure whether you have answered to this question. We have one question from Ramaswamy in the chat.
Okay, let me have a look. Is this the one you're saying? Number of replicas will not exceed the number of partitions on the topic. That is, if max replica count is set more than number of partitions.
Yes.
Because if there are more number of consumers than the number of partitions in the topic, then extra consumers will have to sit idle. Uh, Partitions, I think this concept you're talking about is more related to Kafka.
Yeah, I think Ramaswamy was trying to answer one of my comments. So there was
Yeah.
Indrajit who asked, "Have you tested this application with Kafka?" So I replied to Kinderjit that Kafka doesn't have an API which provides the topic message length. So I'm not sure. But then I looked at KEDA scalars and I found there is a Apache Kafka scalar. So I think then Ramaswamy just pinged me that information. I'm not sure it is a question. He just
That's
pinged me
correct.
that.
That's correct. In case of Kafka, it is the number of partitions and the number of replicas they have to match. Otherwise, the remaining replicas will be idle.
Yeah.
Yeah, that's correct. So this one is dependent on the kind of the underlying infrastructure or the event source that we are using. As we looked at database, right, or the Azure log analytics, these properties would change and they will have to rely on what the source also provides. Kafka, for example, it has a different kind of method or approach, the way it partitions and the way it allows scaling. So we will have to rely on those underlying infrastructure as well at times. That's correct. Thanks for answering that question.
Do we have any more questions? Okay, I think that's about it. Thank you, Nilesh, so much for the session, and thank you all for joining us today. Please feel free to do event check-in and share your feedback about today's session. It will help us to choose a topic that better suit our audiences. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. Thank you all once again and enjoy the rest of your day.
Thank you. Thanks all. Have a nice day ahead. Bye-bye.